Excellent. All right. Thank you guys for listening to me. I too wanted to be there and um, things got complicated. So I am not there. I'm disappointed. When I attended my first NESF a couple summers ago, I said I'm going to be at every single one of these. So I'm not there, but I'm here in spirit. So I'm here to talk about LSII, or the Lunar Surface Innovation Initiative. And I think a few of you are probably engaged through LSIC, I hope. And really, this is one of the ways that we do technology development for the lunar surface. And so just highlight that. And my goal is to help us save some time as well. All right. So just a little bit about LSII for those that don't know. We do this in conjunction with the Applied Physics Lab at Johns Hopkins, but really the goal is to kind of monitor the investments that STMD is making, and really that the agencies making and industry and academia are making as well, and to look across the technology spectrum. And this is to look at the needs that Artemis has, the needs that industry might have as well as we get to the lunar surface. And so we work very collaboratively through LSIC, but there's also other work that APL helps us do kind of behind the scenes to do analyses and studies and datas, and hopefully a lot of you guys have participated in that. And so really ultimately our goal with technology development is to get the technologies ready for the folks that will need them later on, so that we're maturing the right technologies, investing in the right things when they're needed later on. And then historically, we've used flight opportunities in different forms and fashions also to demonstrate technologies. So moving on, just to kind of talk about the different capability areas that LSII focuses on. They're naturally overlined, I think, with a lot of the work that happens in survey and kind of fall into the vein of exploration science. So we've got excavation and construction, dust mitigation, in situ resource utilization, extreme environments, surface power, and extreme access. So those are the areas. The way we kind of manage these areas has evolved over time within STMD, but through LSII, those have consistently been the 6 areas as directed by OMB. And then this is just a little bit more specifically about LSIC, which is the actual kind of interface that we have with the community. And this shows, it's very heavy on the industry engagement, but as you can see, we do have a lot of academic engagement, a little bit of other non-NASA engagement, but a lot of engagement kind of throughout the US, and then we've started to get more engagement internationally over the last couple of years. And so then just to kind of put a plug in for folks that are interested in getting engaged, and just to highlight kind of the difference of some of the engagement that survey offers with some of the groups and forums, is that this is obviously much more heavily focused on technology, but obviously similar interests and areas, and a lot of the work that you guys do, I think, feeds into the technology development gaps and needs that we have. But we've broken it into 4 focus areas that meet regularly. They have usually monthly tag ups, and then we come together as a group for a fall meeting that's held at a university, and then a spring meeting that's held at APL. So that's divided into the cross-cutting capabilities focus area, the ISRU focus area, excavation and construction, and then surface power. So now I want to get to kind of the way that's all tied back to Artemis and to the architecture. So hopefully from listening to Jake and Sarah and Brad over the years, you've picked up on some of the objectives, the blueprint objectives that we've talked about, the Moon to Mars objectives. But STMD, the Space Technology Mission Directorate, where I'm located, we have some ownership over some of the lunar infrastructure objectives. And so I've just kind of posted those here. I won't go over these in detail, but you guys will have access to these charts. But we're really on the hook for getting some of those technologies developed again to a certain point, so that those technologies, whether it's human spaceflight needs them, or Science Mission Directorate needs them, or someone else needs them, that some of that lunar infrastructure technologies are advanced appropriately. So these are the objectives that we look to make sure that we're investing appropriately. Okay, and now to get into some of the kind of the fun technologies, we really do work across industry, academia, within NASA, technology development, and just kind of scan what's going on, where do we need to invest more, and so that can be anything from low TRL investments through SBIR and STRG, the Space Technology Research Grants that include everything from the Instagrow fellowships that go out, or STRGs, which last multiple years. And then we have mid TRL development, which can happen in-house at NASA or can happen through Space Act agreements, or tipping points. And then, ultimately, if we can get, to higher TRL through working on, flight demonstrations or handing things off. And so I want to highlight surface power. That's definitely become an area of high interest for Space Technology Mission Directorate in this last year. At kind of the lower TRL end, one of the things that wrapped up recently was the NASA Watts on the Moon Centennial Challenge, and so that was put out to the public for folks to come up with solutions. And so in the end, two universities won that challenge. One group got $1 million and another got $500,000 for their innovative solutions in that area. And then another power technology that we have is the vertical solar array technology. So we're currently developing those technologies. They're at the mid-TRL level, and that's done with 3 companies, with Honeybee Robotics, Lockheed Martin, and Astrobotic. And so they're working with NASA to get the technologies to the right level so that ultimately these can be integrated into flight systems and used on the lunar surface. So there's some really great objectives and milestones that those technologies have met in the last year or so, and some more to come. And then another big one that hopefully folks have heard about is fission surface power. So that's something that NASA has been working on in collaboration with the Department of Energy. And one of the big changes over this last year is that will be handed off over to ESDMD. And so STMD has kind of done their part to develop the technology to a certain stage and has worked closely with Artemis to say, yes, Artemis recognized the need for this, and that will move over to continued development through ESTMD. So beyond power, another big one is environments and dust mitigation. And so highlighting just a couple of the dust mitigation technologies, again, kind of on the lower TRL spectrum, still looking for innovative solutions, right? And so one of the things highlighted here is an STRG opportunity through a program we had called Luster. And so that actually went to University of Maryland. So I don't know if Christine Hartzell's out there listening or in the audience, but that's the Gecko roller. And there's a picture there of kind of what inspired that, but a really neat technology. And then kind of at the mid-TRL, an internal NASA project is really looking at, the needs that we have to advance motors, going to be not just in dusty environments, but also cold environments. And so there's a lot of needs there, and also just the need to be able to test these things as industry comes up with their own solutions for motors and other dust tolerant components. And then on kind of the higher TRL end, something that NASA's been investing in for a long time is the electrodynamic dust shield. So I'll show a video of that in a minute. Okay, and then on the environments end of dust mitigation, we have a couple of projects that have been advanced, some through collaborations with university, some through SBIRs, and working with industry. And so this is really an area I think is important to kind of highlight to this group here, is that there's still a lot of solutions that need to be advanced, a lot of innovation. And so I think looking, NASA kind of looking out to our partners in academia and beyond to help advance the solutions in these areas. And so I've just highlighted a couple. I won't go into the details here because there's so many. And so we have our ways within Space Technology Mission Directorate and within Artemis to kind of define what the technology gaps are, to say, hey, these are the things that we're going to need the problems we're going to need to solve to go to these extreme environments, the extreme cold, the dust and whatnot. So I think this will be a big area going forward. And then surface sustainability and logistics is another kind of emerging area. The capabilities within this area are things that we've talked about for a while, like excavation and construction and autonomous systems and whatnot. So I've highlighted a couple of the Instagrow, the graduate fellowships that we've funded in this area, which can be anything from climbing robots all the way to there's one that it's talking about autonomous systems on the surface and how resilient they have to be if they're going to be autonomous on their own for quite a while, all the way to we have a system that's done by Aegis Aerospace, the STEF system that's actually flying different materials all the way to the surface of the moon to understand how those materials will act on the surface, and that's going to be demonstrated via clips. And then this is just to highlight on the right that there's just a lot in when we're talking about going to the surface for sustained lunar evolution. There's a lot of in the area of interoperability and maintainability, and going there for sustained periods. There's just a lot of technology development, I'd say, on on the low end that still needs to be solved, but all the way up to when we talk about systems working together and the logistics of moving things around. A lot of that stuff hasn't been solved, and so this is, in my mind, kind of a fun area that there's a lot of work to be done. Okay, so I will end there. I think I have saved us time, and then hopefully that top video is showing. And just wanted to highlight in this last year, the 2025, we had some exciting technology development milestones within STMD. With Blue Ghost Mission 1 and IM2 in the spring timeframe. And so, with IM2, we had the Prime 1 drill and mass spec, and then we had the Nokia COM payload, and then we had the hopper with IM. And so all of those did reach key milestones despite not being able to accomplish all of the milestones they wanted to accomplish. And then with Blue Ghost, we had really great successes with the electrodynamic dust shield, as you can see there. They tested both EDS on glass and a thermal radiator, and then scalps, which monitored the erosion of the dust with the plumes coming down. And we're going to see scalps fly on a couple other landers going forward. So I'll just end with that and leave it for questions if we have any.